Hello all, welcome to my YouTube channel Whiteboard Machine Learning. In this tutorial we will see how basically decision tree tends to overfit. To demonstrate that I have taken a dataset called wine quality dataset and I'll try to import necessary packages over here such as your pandas, okay, and then try to read the dataset name is wine quality-red.csv over here. I'll be reading that file using this read function or read CSV function and store the data inside df over here. Once you have imported the pandas library and you have read the data over here, now what we do is that we go with the basics check. The basic check is all about checking with the missing values, and if you have any missing values in your data set, you should always try to fix that missing values. So in other words, we try to impute the missing values. In this case, I have written three statements over here. The first statement is all about checking with the missing value. The second statement is checking the head of a data frame. And the last one is all about checking the number of values in a column called quality column. I'm going to actually comment this first statement and then the last statement and check what we have inside this particular data set. I'm going to check with df.head. What you can see is that the different columns or different features such as fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide density, pH level, sulfates, alcohol, and finally the target column, nothing but it's a quality over here. So if you could observe here, basically the target column is quality and it has got different scores for the wine qualities, right? So we are going to actually check the wine quality based on the different features what we have taken in this particular data set over here. It means that from fixed acidity to alcohol, they are all called as X features. Now what I do now, I'll go ahead and check how many values are there in our target column quality. For that, I'll be using a statement df.quality.valueCounts function. When I just try to execute that, you can see that we have given different scores for the wine quality, such as the quality 5, quality 6, 7, 4, 8, 3. So these are the score numbers given in between 1 to 10 for the different wines we have. Now what you can see, this is typically the classification problem. So we have the number of counts for wine quality 5 is 681, so correspondingly for 6 is 688, 638, and then for 7 is 199, and then 4 is 53, 8 is only few, 18 over here, and 3 is all about 10 in this case. So typically this is an imbalanced classification and we may have to balance this data. But enough guys, so this notebook will not concentrate on balancing the data set. Okay, so I'll try to create another video where we can always understand how basically we can create some synthetic data and try to balance the imbalanced data set. Okay, so what I'm going to do now, I'm going to go with this particular statement called df.eSnull.sum, wherein I'll be checking the missing values in my data set, so that I'll be checking df.eSnull.sum. When I just check with this statement df.eSnull.sum, what you can see over here, you're just checking whether you have any missing values or not. This data set does not have any missing values, so you can see over here all the features are having zeros as its value. It means that you do not have any missing values in your data set. But that's okay guys, so that's basically how you try to visualize the just see the check with the missing values in a data set and also the head of the data set. Okay, now if I check with the quality column over here, that's basically the last column. It has got different scores for the different wines we have. So what I'm doing is that for my conveniency, I'm trying to map those scores with some values over here. Now I'm going to say something like the wine quality score 3 is mapped with 0, 4 is mapped with 1, and then 5 is mapped with 2, 6 is mapped with 3, and then 7 is mapped with 4, 8 is mapped with 5. So I have taken a dictionary over here. The dictionary is all about mapping the actual score with the score that I'm giving over here. This is all about for my conveniency, and when I go with the confusion matrix, this will definitely help me to analyze the confusion matrix in a much better way. I'm going to actually execute this one, so that will basically create this particular mappings. Now I want to make changes to the target column over here in such a way that I'll be able to see these scores that I'm giving over here. So to enable that, what I am doing is that I'm trying to go with this df.lock. Okay, we know that the lock function will be able to choose columns from your data set. I'll try to choose all the rows, but only one column called quality column, which is now equal to df.quality.map. I'm going to use Python's map function to map this particular dictionary, whatever you have taken. In this case, I'm going to say something like grab the quality column, map with the quality mapping dictionary over here. Alright, so when I try to execute this particular statement, what you can see is that so all the scores, the original scores, are now getting changed to the 0, 1, 2, 3, 4, 5 values what I'm trying to give it over here. I'm doing this in this particular statement, and I'm going with value counts again, which basically says df of quality of value counts. When I tried executing it, what you can see is that the original scores are now being changed to the scores that I'm giving it over here, right? That's basically how you try to map the quality with your own values, by just keeping a dictionary over here and using a map function in your Python. That's done. Once it is done, I'm going with the splitting of your data set. That's basically considering your X and Y. Since this is a supervised machine learning algorithm, I go with X and also Y over here. In this case, you'll have to always identify the input features. The input feature that I have is like from fixed acidity to alcohol over here. These are taken as input feature, that is nothing but X, and the output is basically quality over here. I'm going to do something like this. So grab all the rows, grab all the columns except the last one, which is going to be quality over here. That's basically using this ILOC functions of your pandas data frame, and store it inside X, and then we have got Y over here. For Y, it should be always the target column, nothing but the quality. I'm going to say something like Y is equal to df dot iloc of grab all the rows, but last column nothing but -1. Okay, I'm going to use the negative index over here to indicate that I'm accessing only the last column -1 over here. So the index number for this in the reverse direction is -1, -2, -3, -4, -5, etc. I'll do that so that the X and Y are ready for me. So you can always check what is there inside your X by just checking with X, and what you can see over here, it's all about the input features in your dataset. And how about your Y? So Y is all about your output one. That's basically the wine quality scores that I have assigned earlier over here. So once it is done, it is always good to split your data into 80% training data and 20% test data. Remember, this is called as the validation approach, wherein we try to go with 80% split and 20% split. 80% is all about the training set and 20% is all about the test set. You can always vary the sizes of this training set and the test size, and it is all in your hands and how you carry your analysis. Now in this case, I'm going to pass in your X and Y to this train test split function that I am trying to import from model selection package, and then I pass in your X and Y, set the test size is equal to 0.20, 0.20, that's basically 20% test data, and you'll have to always fix the shuffling by setting your random state is equal to some random value. In this case, I'm basically using 10, so that you execute this particular cell for multiple times, you get the same shuffling. I'm going to actually resolve this or unpack these variables. Now xtrain, xtest, ytrain, ytest will have the corresponding test data and the train data. You can always check with the shape of it by just executing xtrain.shape, xtest.shape. Xtest is all about 20% data, and then xtrain is all about 80% data. When I try to execute this one, what you can expect is all about the shape of this data set, like 1279 comma 11 columns. That's basically 80% data from your data set, wine quality data set, and 320 into 11 is basically your test data, right? That's basically 20%. Once I do that, I'll just go ahead and I'll try to import your decision tree classifier from scikit-learn tree package, and I'll try to set one of the hyperparameter over here saying that the max depth of the tree is equal to 3 in this case. Remember, this has to be tuned. For now, I'm just keeping it as 3 over here and trying to initialize this tree model in this case. Once I've done with that, I'll take this training part and try to pass it to the fit function of model. When I try to fix that, so you can always see that the model has been trained with 80% data, so which is nothing but your X train and Y train. And what you can see over here, so this decision tree that you're going to create will have a depth of 3. Make sure that you always test both your training part and the test part. What I'm going to do in the next cell is that I'll be considering these predict functions both on training data and also the test data. See, it is very important to always diagnose your model, always try to draw the learning curves of your model so that you can understand what's basically happening during the training phase and the test phase. In this case, what I'm trying to do now is that I'll be considering this tree model and try to use the predict function and pass in the X train data over here. X train is all about the 80% input, and I'm going to make the predictions on the X train. That is very important, and whatever the predictions I do, I'll be storing that inside train underscore predictions. The same thing I'm also repeating on the 20% data, saying that tree model dot predict on X test and store all the prediction inside your test underscore predictions. Just execute it. It is always good practice to check how well your model is behaving on your training data and also the test data. Okay, because we're trying to understand the concept of underfitting and overfitting over here. Now if we just check with the test predictions over here, so what you can expect is all about the predictions made on this 20% data. That's basically your 320 records. Okay, and then if I check with the train predictions, you can expect to get like the train predictions. You can expect to get the predictions on your 20% data over here. That's basically tree model dot predict on X train and then tree model dot predict on X test over here. I'll just try to comment this, which is not required for a while. Now it is always good practice to check the accuracy score both on the training data and also the test data, because we wanted to know how well your model is generalizing on the test data. In that cases, I'll be going with the accuracy score, and it is basically Y train comma Y train predictions, nothing but you'll have to consider this train underscore predictions and pass in the actual labels of your training part Y train. And even with the Y test, so Y test is a true label or the actual labels, and test predictions is what you have predicted and stored inside this. Once I just execute that, so you can expect to get around 57 and 52%. It means that the model is not learning better. Remember, the reason is because we are taking only max depth is equal to 3 and number of features you have in your data set is many over here. Okay, so max depth 3 somewhat seems to be very small value. Then we have to tune this max depth in such a way that your model will not underfit. Remember, I use a concept called as underfit because your model is not performing well during the training phase and also well during the test phase. It is not performing well even in two different phases over here. That's why I'm calling this model as the underfitted model. But anyhow, the agenda to understand how well your model is basically getting trained, okay, as you try to increase the number of depth over here. Now in this case, I'll check with the overfitting of the model. So for that, I'm going to say something like this, guys. I'll just come over here and then I'll try to import the tree, which I've already done it here, and then the metrics, okay, because I want to have the accuracy score over here. And then I want to plot the graph. That's why I'm taking this matplotlib.pyplot as PLT and also the Seaborn package, such a way that I can actually plot the learning curve. I'm going to create two empty lists over here. One is to record all the training accuracy for different depth and also the test accuracy over here. Now what I'm doing is that I've taken a for loop. The for loop is basically for depth in range of 1,25. I'm basically taking a range of values. The loop will iterate for 25 times right from 1 till 24 over here, excluding the 25th value over here. It means that we are going with a different depth value starting with 1 and ending at 24 over here. So you'll have to place all the necessary statements, such as you'll have to say something like max depth is equal to depth here, because the depth variable in this for loop is taking different values in this case. Whereas in the previous cell, what we did is that I was explicitly specifying the max depth is equal to 3, and your model was not actually performing well. That's okay, but the agenda of this notebook is to check how basically your model tends to overfit. Okay, now in this case I try to initialize this particular decision tree classifier with the max depth is equal to depth. In every step or in every iteration, the depth will take the different range of values, right from 1 till 24. Now once you have initialized this, then you should always try to fit your model on the different depths. Okay, so starting with depth is equal to 1 till depth is equal to 24. So I'm going to say something like tree model.fit of x train comma y train, and also make the predictions for every depth you have taken. Tree model.predict on x train and tree model.predict on x test over here. Store all the predictions inside train predictions variable and test predictions variable, and once you have done with that, it is always good practice to calculate the accuracy both on the training data and the test data, because we want to know how well your model is basically working or testing on the unseen data like the test data. I'm going to say something like metric start accuracy score, pass in your Y train and also the train predictions. It means that whatever the predictions you have made in this particular statement and the actual or the true labels what we already have in our data set. And also I'm trying to repeat the same step for the testing part. Y test comma test predictions will be passed to metric start accuracy score over here, and then store all the training accuracy and test accuracy for every depth you consider in your for loop. And finally, I try to append this empty list that I took initially over here. That's basically train accuracy and the test accuracy, which are the empty list in this case. I'm going to say something like train accuracy dot append of train accuracy. Whatever the accuracy I get for every depth, I'm going to actually append it to this train accuracy list over here, and then test accuracy is being appended to test accuracy over here. Once you're done with that, once you're looped this for loop for 25 times, going with the different depths, okay, we have recorded the train accuracy and the test accuracy. Using this training and test accuracy, I'll try to plot a graph now. If you just observe over here, I'm setting the figure size is equal to 10,5 over here, the width and the height of the figure, and set the style of the figure by using the style function set underscore style of white grid. Okay, that's basically from your Seaborn SNS. And also I'm trying to plot these two graphs, such as your pld.plot, pass in your train accuracy. I want to see the legend, that's why I'm setting this label is equal to train accuracy, and then plot test accuracy, pass in your label is equal to test accuracy. And finally I'm also setting this legend. Legend is all about the information what is can see over here. Okay, I wanted to see these two lines like train accuracy and the test accuracy. In this case I'm going with the legend, and the location is equal to upper left over here. If you just observe this graph, so we have placing this legend at the top left corner over here. That's why I'm saying that lark is equal to upper left in this case. I'm also setting the ticks over here. The ticks is basically ranging between like 0 to 26 with the step size of 5 over here. That's basically your x ticks from your PLT, and what I can see on the x-axis is the number of depths. 0, 5, 10, 15, 20, 25 with a step size of 5 over here. As the depth increases, okay, we'll have to see how well your model is behaving, whether it is tend to overfit or to underfit in this case. Now in this particular statement, I'm going to set this max depth is equal to x label is max depth, and the font size I'm setting it to 20 over here, and y label is all about the accuracy. Set the font size is equal to 20, and try to show the graph by just saying that plt.show over here. Now when I just check with this one, guys, what I can observe is that a plot, okay, on the x-axis we have a max depth, and on the y-axis it is all about the accuracy, and the legend basically says the blue line is all about the training accuracy, and the orange line is all about the test accuracy. See, as I told you earlier, the decision tree always tends to overfit as you increase the number of depth. In this case, we always want to analyze your machine learning models both during the training phase and the test phase. What you can observe from this is that as the number of depth increases, your model is becoming over specialized, and it is giving us 100% accuracy, what you can see over here. Okay, so along this y-axis, but your model is performing really well on the training set, but it fails during your testing phase. What I can observe here, as the depth increases, the accuracy is not increasing. It is like somewhere in the range of 60% or in between 65 to 60% over here. We'll have to see a learning curve something like very close to the train plot over here. Okay, it means that we need to see this orange line to be plotted very close to this uh, blue line, which is the train accuracy. What you can observe here, your model is overfitting, nothing but your model is becoming over specialized only during the training phase, and then your model is perhaps like not performing well during the test phase, right? So this is what we'll have to always observe when I say diagnosing your model by drawing this learning curve. Now, how do you overcome this problem? You'll have to tune your depth with other hyperparameters, okay, considering in your decision trees. But anyhow, guys, there is always a option to overcome the problem of overfitting. That's basically called as k-fold cross validation. In the subsequent lectures, I will also discussing what is a k-fold cross validation and how we can overcome the problem of overfitting in your tree based algorithm. I think that's it about this tutorial. Thanks for watching. If you like this video, okay, please subscribe to my channel. Thanks very much. Bye.